So we're going to have a look at how to build a Born Haber cycle. I'm going to start off with a simple one. So I'm going to select to do this one here. So formation. I've got an enthalpy of formation for lithium fluoride, minus 616. So let's have a look at that one. So you've got your structure here, and it says cut out, but obviously we don't cut out the various equations on the previous page. Choose one of the compounds for which there is an enthalpy of formation and place the relevant equations into the grey boxes. So the first thing that I'm going to do is I'm going to place lithium fluoride, which is my solid ionic compound. Lithium fluoride is here. It's a solid ionic compound. The elements in their standard states, so that must have been lithium is how it began, and fluorine is how it began. But fluorine doesn't exist in its standard state as a F, it exists as an F2. So F2. Because there's only one fluorine present in lithium fluoride, that means I only need to start with one fluorine. So I have to have a half of a fluorine. So I put a half there. Half of F2 means I have one fluorine atom. So I've got lithium in its standard state is going to be a solid metal. Fluorine in its standard state is going to be as a gas. Then if I look at my data, the enthalpy of formation for lithium fluoride is this one here, minus 616 kilojoules per mole. So here I put minus 616 kilojoules per mole. That's the first start on my Born Haber cycle. This over here, the lattice enthalpy, is the thing that I'm trying to actually calculate. And I have to figure out what all of the different stages are to figure out what the difference is between here and here. So when we're looking at this, it exists in a series of stages. You have to change the metal, you have to change the non-metal, but you have to do it step by step. So the first step, it doesn't have to be in this order, but this is a really good template to use. Place the non-metal enthalpy of atomization here. So the non-metal is fluorine. The enthalpy of atomization for fluorine, if we have a look, we can see it here. So atomization is turning a fluorine molecule into a fluorine atom in its gaseous state, and that is 79 kilojoules per mole. So here, 79 kilojoules going in that direction. Once the fluorine's been atomized, it then becomes F rather than half F2. It's in its gaseous state because that's necessary for atomization to take place. The metal, nothing happened to the metal, it's still exactly the same. We can only do one thing at a time. So we've gone from lithium with the fluorine into lithium and then a fluorine atom. The next stage, place the metal enthalpy of atomization here. So the lithium is our metal. This is its enthalpy of atomization, 161. So 161 represents an energy move in that direction, and it represents lithium solid turning into lithium gas. Atomization, gaseous atoms. The fluorine, nothing's happened to the fluorine. It's exactly the same, one thing at a time. The next thing, place the metal enthalpy of ionization here. So lithium is the metal. The enthalpy of ionization, lithium going into a lithium ion, is 520 kilojoules per mole. So 520 kilojoules per mole going in this direction. What's actually happening? Lithium is becoming a lithium ion. So here I'm now going to have lithium as an ion in its gaseous state, and I'm going to have fluorine in its gaseous state because nothing's happened to it. I'm also going to have the electron, the electron that was removed from the lithium. So that is going to be hanging around. Once we've got to this stage, if we look at the cycle, we've got another action to do, which is to calculate or to look up the electron affinity for the non-metal. Now, electron affinities tend to be in the opposite direction in terms of energy. So the non-metal is fluorine. So fluorine is turning from a fluorine atom to a fluorine ion, a fluoride ion. So fluorine gas goes to a fluoride ion, gaseous. It took the electron that we've got here to do that. We've got the lithium, which is exactly the same as it was before. Nothing's changed to the lithium because we can only do one thing at a time. Fluorine turning into fluoride ion. Fluorine turning into a fluoride ion. -3 to 8. -3 to 8. So because here we're moving, the arrow is in an opposite direction. This is representing a negative energy change. And that's why we've got the minus on this sign over here. So fluorine plus an electron going to an F- ion, -328 kilojoules per mole. Now we have all of the data input. Let's check. Each of the grey boxes has information. We have enough information to figure out the lattice that's asked of us underneath. So if I can say everything on this side must add up to the same that I have on this side. They're the same distance, if you like, from here to here. From here to here. Whatever the value is on the left-hand side, the value should be the same on the right-hand side. So the next stage that I would do is I would try to travel. I would try to travel from lithium fluoride up, let's use a different colour, up in this direction, up in this direction, up to the top. So that means that the arrow that I'm thinking of in terms of my direction of travel is going up. If I'm going up, I have to flip my sign. -616 is the energy change from here to here. The energy change from here to here is going to be +616. So on the left-hand side, I have +616, I have +79, I have +161, I have +520. So let me just do that on the calculator. So 616 plus 79 plus 161 plus 520 gives me 1,376. No idea what happened there. So that is the energy on the left-hand side. The energy on the right-hand side is equal. So the energy on this side also has to equal 1,376. Now, because I know that of that 1,376, 328 of them are required for the movement of the fluorine atom to become a fluoride ion, then by simple arithmetic, 1,376 take away 328 gives me 1,048. So this represents the energy that is here. So both of these two values added together equal the same as they do on this side. Now, the sign, is it a positive or is it a negative? If we are calculating in this direction, then the sign is positive. If we are calculating in this direction, then the sign is a negative. So you look at the direction that the arrow is asking you. The question is asking you about the arrow in a specific direction. In this case, it's asking us about an arrow moving in this direction, so lithium fluoride to lithium ions. So in this case, the energy change is going to be plus 1,048 kilojoules per mole.